Welcome to Unit 10. This unit is on measurement, area, and volume. So we're going to do some more geometry topics. We did some stuff with triangles in the previous unit. We did some right triangle stuff with the Pythagorean theorem and right triangle trigonometry and the trig ratios. And we're going to go on into some more of the basic concepts and work our way into some very important information that we're going to need to know, especially by the time we walk into Algebra 1 and geometry. Alright, we're going to start here with lesson 10.1 on triangles. And as I have written down in the last unit, we classified triangles by angle measures. Remember, if all three angles were less than 90 degrees, acute angles, it was called an acute triangle. If we had one angle that was a 90-degree angle, a right angle, it was called a right triangle. We have acute triangles. We have right triangles. If one of the angles of the triangle was more than 90, it was an obtuse angle, therefore it was an obtuse triangle. Obtuse here. And if we had all three angles being the same size, the same measure, we call that equiangular. Now, that would mean that all three angles have to be 60 degrees because, as we also mentioned, when you add up the angles of a triangle, it adds up to 180 degrees, the three interior angles. So three angles of all the same size that add up to 180 degrees, they would all have to be 60-degree angles. We call that equiangular. It's a special type of an acute triangle. Now we're going to classify them not merely by angle measurement, also by side length. So by side length we have the following. We have equilateral. Equilateral equals sides. Lateral means sides. It means all three sides are congruent. As it turns out, if you have an equilateral triangle, it's also equiangular and vice versa. They kind of go hand in hand. The next type is called an isosceles. Isosceles. I have trouble spelling that sometimes. I-S-O-S-C-E-L-E-S. An isosceles triangle is a triangle that has at least two congruent sides. Now, because it says at least, it could be more than two, it could be all three. That would mean an equilateral. It's just a very special type of an isosceles triangle. And then the third type is called scalene. Scalene means none of the sides are congruent to one another. You have three sides all of different measure. We're going to do a couple of problems here, and then we're going to classify the type of triangle we have either by side or by angle. So in this first example, it says find the unknown side length of the triangle given the perimeter. Now this is the perimeter right here. The perimeter, remember, is all the way around. You add up all three sides of their lengths. Then it says classify it by its side length. So we know in this case that if we add up the three sides, we should get 65. So that means x plus 30 plus 25 equals 65. These are like terms. I have x plus 55, 30 and 25, equals 65. If I subtract 55 from both sides, I get x is equal to 10, and that would be my measure. This would be 10 yards. So since all three measures are different, okay, this being 10 yards right here, we know it's scalene. That's how we would classify it by its side lengths. Now I'm going to go back to the angles. It says for triangle STU, the measure of angle U is 23 degrees, and the measure of angle S is equal to the measure of angle U. Find the measure of angle S and find the measure of angle T and then classify it by its angle measurements. Well, that means we're going to use one of these names up here. Well, if the measure of angle U is 23 and the measure of angle S equals the measure of angle U, that means that the measure of angle S is also 23 degrees. We need to find the measure of angle T, and then we'll be able to classify. Well, remember, all three angles have to add up to 180, so I have two of them. I have this one here and I have this one here. So that's 23. 23 has to add up to 46. This would be in degrees. Then I subtract from 180. 46 from 180 gives me 134. So this has to be a 134 degree angle for measure of angle T. That means I have an obtuse triangle. Classifying it here, an obtuse triangle, because I have one angle that's clearly more than 90 degrees. This one was a scalene triangle. The little triangle symbol, it represents just that, a triangle. So you can go ahead and write that down instead of the word. Alright, we're going to go ahead and look at some other types. Okay, now we're going to work some problems out here where we have the triangles and we have measures of some of the angles but not the measures of all the angles. We're going to find the value of x and then we're going to classify the triangles by their angle measures. Now again, we know that all three angles have to add up to 180. So I'm going to have x plus, that's this angle, 3x plus, that's this angle, 102 is equal to 180 degrees. X plus 3x is 4x. We combine like terms. It's like 1x plus 102 equals 180. I'm going to subtract 102 from both sides. And I get 4x is equal to, looks like 78. Then I'm going to divide through, did I get that right? 78. Then I'm going to divide through by 4. And this one's not going to come out evenly. What was I thinking here to get one that did not come out evenly? I get x is equal to, that would be for 19 and a half. Yikes. So x turns out to be 19 and a half. Now that's the value here. They wanted the value of x, so we know that this one is 19 and 1/2. This is 3 times x. 3 times 19 and 1/2 would be 58 and a half. Now we don't need that measure other than the fact that we want to classify the triangle by its angle measures. Well, it's got an obtuse angle, so this is an obtuse triangle. So those are the two answers for that one. Alright, now the next example I think is going to be a little bit easier, and I think it comes out evenly. Well, again, same concept. It has to add up to 180. So I have 3x for this one, and 3x for this one, and 60 for the third angle, and that has to add up to 180 degrees. That's 6x, 3x plus 3x, plus 60 equals 180 degrees. I'm going to solve this one, undo the adding or subtracting first, then divide, and this turns out to be 20. 6 goes into that 20 times. Now that's the first answer. They wanted x. You're to classify, so if I plug 20 in here for x, 3 times 20 is 60, 3 times 20 is 60. It is acute, but even better because they're all the same measure. I'm going to call this equal angular. Equal and angle measures. It's just a very special type of an acute triangle. This is an equal angular triangle. Now we go to the sides here in this next example. Find the unknown side length of the triangle given the perimeter P. Then classify it by its side lengths. Well, in this case, this little notation here represents the fact that this measure is the same as this measure. So we know it's isosceles, but we don't have the measure, we just have the perimeter. So I'm going to call this side x, length x, and I'm going to call this side length x since they're the same. And I'm going to do something like this, only I'm going to add up the sides and set it equal to the perimeter. I'm going to add this side x plus this side x plus this side 18, and I'm going to set it equal to the perimeter, because remember, you add up all the sides, you get the perimeter. 1x and 1x is 2x plus 18 is equal to 48. I'm going to subtract 18 from both sides. I get 2x equals 30. I divide by 2 and I get x is equal to 15. So this is 15 inches and this one is 15 inches. Find the unknown side lengths of the triangle, so definitely 15 inches would be the lengths of the unknown sides there, and classify it by its side lengths, well, it's isosceles. I always want to leave out that second S in isosceles for some reason. Alright, now, we're going to go into other types of shapes. Now, triangles are fine. We've talked about the angle measures, we talked about the side measures and the different names and ways they can be classified, but they're just one type of what we call a polygon. Now, a polygon, by definition, is a closed figure whose sides are segments, line segments, that intersect only at their endpoints, which means this is not a polygon because it's not closed. See the opening right there? This is not a polygon because these two sides here don't intersect at their endpoints, they intersect somewhere in the middle. So polygons don't have to have just three sides, by the way. I mean, think about squares and rectangles and some of those types of shapes. Those are all examples of polygons. Okay? Now, a special type of polygon is called a regular polygon. It's a polygon in which all the sides have the same measure and all the angles have the same measure. And my example that I always tell students is to think of a square. If you have a square, not only are all the angles right angles, so all the angles are of the same size, but all the sides are of the same length. That's an example of a regular polygon as a square. So is an equal lateral or equal angular triangle. Because as this turns out, not only are the angles all the same measure, the sides are all the same measure, because equal angular and equal lateral go hand in hand. That's a regular polygon. So we're going to discuss this in more detail and do some specific types of polygons. A definition of a convex polygon, okay? Now, a convex polygon, we haven't talked about that. It's a polygon in which two interior points can be connected with a segment that lies completely within the polygon. Now, that sounds kind of weird. It's a little abstract, but I'll show you with the example here in just a moment. So, a convex polygon, two interior points can be connected with a segment that lies completely within the polygon itself. A concave polygon is a polygon that's not convex. This is an example of a convex polygon right here. No matter what 2 points I pick, if I connect them with a line segment, it lies completely within the polygon itself. On the other hand, this one here, if I pick this point and I connect them with a line segment, you can see that my line segment, some of it is in the exterior of the polygon, not within the interior, but within the exterior. So, this is convex, this is concave. Now, I always thought of concave like a cave, how a cave kind of goes into the side of a mountain, perhaps, kind of dents in like that. Now, polygons are also, primarily, are named by the number of sides that they have. Now, we already know that if it has 3 sides, it's a triangle. 4 sides, it's a quad, that means 4, quadrilateral, lateral sides, 4 sides. 5 sides is a pentagon, like the Pentagon building that has 5 sides in Washington, D.C. 6 sides is called a hexagon. 7 sides, a heptagon. 8 sides, like a stop sign, is an octagon. 9 sides is an nonagon. 10 sides is a decagon. And if you have n sides, we don't know how many sides there are, we just say n. We call it, believe it or not, an n-gon. Okay, that sounds made up. So that's how we're going to classify polygons, by the number of sides that they have. Alright, now we're going to tell whether the figure is indeed given, is a polygon. And if it is a polygon, we're going to classify it by how many sides it has, and we're going to tell whether or not it's convex or concave. Well, the first example, notice it is a polygon. All line segments, no openings, no crossing of lines. They all intersect at their endpoints. So this one, yes, is a polygon. Okay, it has 1, 2, 3, 4, 5, 6 sides. That means it's a hexagon. And it is clearly concave. The reason I can tell you it's concave is if I put a point here and a point here, and I draw a line segment between them, it will go into the exterior of the figure. So it kind of caves in on the sides there. This example here is not a polygon. And the reason it's not is even though it has some line segments here, it also has curves here, and that means it is not a polygon, so I don't have to go any further than that. Now we're going to do a lot of work with quadrilaterals. Remember, those means 4 sides, and so I've listed some of the special cases of quadrilaterals. You have the trapezoid. Now, a trapezoid is a quadrilateral, 4 sides with exactly 1 pair of parallel sides. So I'm going to try to draw it out best that I can here. So that this is parallel to that. That's the little symbols I'm going to use for a parallel. 4 sides and exactly 1 pair of opposite sides here. These are opposite sides. These are actually called the legs of the trapezoid, and these are called the bases of the trapezoid. The bases are parallel to one another. A parallelogram, very important, looks kind of like a rectangle that's kind of tipped over a little bit. It has 4 sides. It's a quadrilateral with both pairs of opposite sides parallel. Now, I didn't draw this very well, but this is parallel to this, and this is parallel to this. That would be an example of a parallelogram. All sorts of properties about parallelograms you'll study in geometry. A rhombus is a very special type of parallelogram. It has 4 congruent sides. So it looks more like a square that's been tipped over. I did not draw that very well. These are parallel, and all four sides have the same length. If you can read that notation, good luck there. A rectangle, everybody knows what a rectangle is. It is a special type of parallelogram. Believe it or not, this is a parallelogram because the opposite sides are parallel, but it also has four right angles. So that would be a rectangle. And then a square, which is just a special type of parallelogram, it's actually a special type of rectangle, has four right angles, and it also has all four sides congruent to one another. Those are your special types of parallelograms. You should make yourself familiar with some of this vocabulary, know these names. Let's classify each of these quadrilaterals that I've drawn out. Here I have a quadrilateral, four sides. I have the notations, the symbols here that represent that these two sides are parallel. That's all I have. I don't know if these are parallel or not, so this has to be a trapezoid. Now in this case I have a quadrilateral and I have the notation, nothing about parallel, but I have all four sides that are congruent. Now if all four sides are congruent, it's either got to be a rhombus or it's got to be a square. And in this case, since I don't have any information about the angles, this has to be a rhombus. Now in this example here, I have four sides, quadrilateral. I have four right angles, which means it has to be either a rectangle or a square. But since these symbols mean these sides are the same length and these sides are of different length, I've got to write this one down as a rectangle. I don't know if all four sides are listed as being congruent. It doesn't show enough. It just shows opposite sides are congruent to one another. By the way, these corners, these are called vertices. I think I've mentioned that before, but I want to kind of emphasize that because I want to use that terminology here in just a second. Definition. A diagonal of a polygon is a line segment or segment that joins two vertices or corner points that are not consecutive or adjacent. I have four vertices here. These two are consecutive, one right after the other. These two are consecutive, these two are consecutive, and these two are consecutive. Alright? However, these two are not, and these two are not. If I draw a line segment like this, this is referred to as a diagonal. And this actually has two diagonals. Kind of looks like a kite. Okay? Now, we know that the sum of the angles of a triangle always add up to 180. Well, the sum of the angles, the measures of the angles of a convex quadrilateral always adds up to 360. So for a triangle, 180. For a quadrilateral, 360. And here's an example where I've drawn one out and I want to find out what x is. Now I know that all four angles have to add up to 360. They're measures. So right here, I'm going to add 108 plus 6x plus 11, that's up here, plus 5x plus, well that's 90 degrees because that's the right angle symbol, plus 90, and that has to add up to 360. I'm going to combine like terms. I have 11x, I have, let's see, 108 plus 11, that's 119. 119 and 90, 119 and 90, that's 209, plus 209 when I combine my like terms here, and that equals 360. I'm going to subtract 209 from both sides, and if I do that, I end up with 11x is equal to, that's a 1, that's a 5, and that's a 1. I get 151. Again, I don't know why I would put a problem that wouldn't come out evenly, but I did. I have to now divide both sides by 11. It's not going to come out evenly. I'm going to get x is equal to, let's see, 12 is 144, so 12 and 7/11. There's quite an answer for you. Now, I wanted to make mention of one more special type of quadrilateral. It is a concave quadrilateral. I drew something like it before, and this is mostly for you Star Trek fans. You guys probably have seen this symbol before. It is a concave quadrilateral. This is called a chevron, just like the gas station. Just throwing that one in for free. So make sure that you look this over and practice, practice, practice.